This video is the start of the next section of organic chemistry, which includes carboxylic acids and organic bases, which are amines, and also things that are related to acids, acid derivatives. And so the first thing we'll see here is just about the naming. So this follows the same patterns that we've seen before. So here's our acid group, the COOH there, and there's C double bond O with an OH. We saw this briefly, the oxidation of aldehydes and primary alcohols. This can be the product of that reaction, an acid. And so we always look for the longest continuous chain of carbons, and we number those carbons. So that would be carbon 1, this is 2, that is 3, and name the main chain, that's prop. Keep the AN or EN, it could be EN, but it's not. It's all just single bonds here. And then the ending oic acid, propanoic acid. And if there are side groups, then they get named at the beginning. So we can notice the priority here again. And notice that carboxylic acids are right at the top. They are the top priority. And so they will always get the ending. So actually here, you're not likely to have to use any of these higher priority prefixes. They'll get the suffix preferentially. But these ones, hydroxy and amino, you are likely to see those quite a bit. And many of you will know about amino acids, and the amino, the amine group, the nitrogen group, gets put at the beginning of the amino acid. So yeah, but the carboxylic acid highest priority means it gets the number 1 carbon. It's always on the end. So I didn't need to say 1 propanoic acid, but I could have. But because it's always 1, we don't need to say it. So maybe I'll do one more example. Here's a slightly more complicated example. The longest continuous chain of carbons is 4 carbons long. And then we have 2 side groups. We have an alcohol group on the side and a methyl group on the side. So for the main chain, that is butanoic acid. The word acid is part of the name. You do need to include it. And then here, this would be then referred to as a hydroxy group as a prefix. And this one, you know, is a methyl group. And there's carbon 1, 2, 3, 4, because the acid is the priority. It gets the lowest number carbon. And again, for these, it's just alphabetical order. So H comes before M in the alphabet. So it's 2-hydroxy, 3-methyl-tanoic acid for that one. And that is it. So we can do some, well, I'll give you some practice, and hopefully you can ask any questions if you had any about that. But there are some other types of compounds, and these are going to be all of them. These are the last ones. Amine group is the nitrogen group with at least 1 carbon somewhere around that nitrogen. Makes it an amine instead of an ammonia, which you already have heard NH3 many times. Notice the name's similar. And there are 3 choices for naming these. That's not to make it difficult, it's actually to make it easier, because sometimes one way is easier than another way. But first, maybe I'll give you the standard way of naming them, the IUPAC standard way, just like we do for everything else. Okay, so for this one here, there's our nitrogen group with just nitrogens and hydrogens. And so that is the ending for amines is just amine, the whole thing. So our longest carbon chain is 3 carbons, and it is an alkane. and amine. And we do need to say where it is, because here you can see it's on carbon 2, could have been on carbon 1. So 2-propanamine. If you put the 2 in the middle here, that's fine as well, just like always. And so this one here, we've got, I put the nitrogen in the middle. Now that's a little bit tricky because the longest continuous carbon chain stops there because there's a nitrogen there in between these two carbons. So I can't, it's not actually a 4-carbon chain, it's only a 2-carbon chain. So that's ethanamine. It is 1, but then we've got a side group. That's an ethyl. We always have to say where the ethyl is. The ethyl is on the nitrogen. It's not on the carbon 1. It's on the nitrogen, bonded directly to the nitrogen. So we can put the letter N to show where that is. So the second choice, and we saw this for one of the examples with alcohols, is sometimes it's easier or people like better to use the prefix instead. That is okay. It's not standard, but people will still understand what you mean. So for this one, I could name that as 2-amino propane. So instead of putting the amine at the end, like the standard way, we can use the prefix amino. So that's only easier when we have NH2. It's just a nitrogen with 3 hydrogen groups. With this one here, it would be really strange and much more difficult to name using that method. The last one is actually a nice one for this style where we have the same thing around the outside. So we can name with just the amine as the main group and all of the carbon groups around the outside as side groups. So this one here, we could call that diethyl amine. So we've got ethyl and ethyl around the amine. And we saw that reaction, that substitution reaction, where it can substitute all sides of the nitrogen group. So this one here would be trimethylamine. So if we have the same thing around the outside, then it can be useful to say, okay, I'm just going to say amines in the main group and name everything else like it's on the side. You could say NNN, but usually for this style we don't because it's obvious. It has to be on the N. The N is the main chain, the main group. So there are lots of different ways we can put together this amine. So sometimes one way is easier to use than the other. The standard way always does work. It just sometimes makes a long name. So finally, there are also 3 acid derivatives. They're things that are, their structure is related to acids. So here I've just put first, I think it's the easiest one to name, is an acid chloride group. So the only difference there is we've got this Cl instead of the OH. And we're going to see these can be really useful because they're very reactive. So they're good for making other things. But for naming this one, it's pretty simple. The acid chloride group's always on the end, and it just gets the ending OYL chloride. So this one here is pent because it's 5 carbons long. Pentanoyl chloride. Always keep that AN. There's also something called an amide with a D instead of an N. And so that's not just an N, that's a C double bond ON. This changes its properties completely. It's very different from an amine for its properties. And so it should have a different name. So there's a pretty simple one. So that's ethanamide. Again, like the acid chloride and the acid and the amide has to be on carbon 1. It must. The last one here is ester. Now this one's interesting because it has got an oxygen in the middle and carbons always on both sides. So I've got 3 examples here. The key here is that this carbon with the C double bond O is part of the main chain. So there is our main chain group. Then there's a gap because there's an oxygen here. So we can't keep counting those other carbons. Those carbons will be on the side group. So the main group is propanoate, and then the side group is just ethyl. You don't need to put anything in front of the ethyl. There has to be something on the oxygen. It must be on the oxygen if it's there without anything in front of it. Ethyl propanoate. So then I've got this one here, and I've got that one to show it's not necessarily the left side. Find that carbon with the C double bond O and find its chain. So this is actually exactly the same. That is ethyl propanoate. It's just written in the opposite way from left to right. But what about this one? So we do the same thing. There's our main chain. Oh, that's only 2 carbons. So this one, and again, I've made it look kind of similar. Hopefully you can see the difference. So that's ethanoate as the main chain, and the side group is propyl. Propyl ethanoate instead of ethyl propanoate. They are different, although these two up here are the same. So that's the ester's slightly trickiest one, and you can have side groups as well, but that's the main idea, is finding that chain. So we'll do some practice when I see you. See you soon. Bye-bye.